me. Okay, just ignore it. It's fine. Okay, so where we are going to start, and the reason why I want you to have a piece of paper and a pen is we're going to start outside of the course specs. All of the standard logic for these standard algorithms can be found in the course specs, and we are going to spend some time in there. For the moment, we're going to start with the first set of logic, which is finding maximum and minimum values in an array. What I want you to do is two things simultaneously. Obviously, we're going to be writing out the pseudocode. That's where we want to get to. How do we write the logic for this? Our end goal is to have a perfectly precise piece of pseudocode. But I just don't want you to memorize the pseudocode. I really need you to understand what it is you're actually doing. That's why we're going to work outside of the course specs. And then we're going to come back and check ourselves and see where we're at. A reminder, conveniently from my previous lesson with year 11. All logic is made up of a combination of control structures: sequence, choice, or repetition. Yeah, sequence, choice, or repetition. Binary, multi-way, pre-test, post-test, counter. It's not too complicated. What we want to do is first off, look at the problem, see if we can work through what the instructions might be, and then see if we can work out a way in which we organize those. So let's roll. Finding minimum and maximum values in an array. Let's start with the concept of an array. What do I usually use to explain? What example do I usually give that an array is similar to? An array is kind of like a list. Thank you, Owen Mitchell from the back. An array is kind of like a list. Okay, so when I write it, I usually write the name for the array equals a series of numbers. Okay, I'm trying to find, let's start with maximum. I'm trying to find a maximum value in an array. Okay, so we're going to write a temporary array on the board. Then we're going to see what the logic might be. So I'm going to call my array numbers. Yep, they can see it. Checking everyone can see it. Numbers. Okay, I'm going to purposely write the maximum value hidden somewhere in the middle. Yeah, or towards the end. Why, when I'm working through an example of finding a maximum value, would I want to hide it somewhere in the middle and the end? In the test data that I'm using, why would I want to hide it in the middle towards the end, Cooper? Yeah, test the logic. If I put the maximum value right at the start, won't give me an opportunity to test. When you're coming up with test data, always see if you can give yourself a couple of chances at the logic. Yeah, a place where you can give it a couple of goes and easy predict, go, I think that's what I know that's what it's meant to do at that spot. Did it work? Did it not? So numbers 2, I'm having a very small array, 7, 12, 6. Okay, that's my array. 2, 7, 12, 6. I'm trying to find the maximum value in it. I'm trying to find the maximum value. Okay. What am I obviously going to be looking for? You've got the test data. You can see the array. You're a human being. What's the maximum value? 12. This is where I want it to hit. This is where I want it to hit. I want it to hit the 12. Okay. Set of instructions. Set of instructions. I'm going to give you a couple of minutes to talk to the people around you. I'm going to start you off, then I'm going to give you a couple of minutes to continue. Finding the maximum value in an array. Where would the logic start? You could start there. My code is finding the maximum value, the maximum number of items in there. I'd probably load the array. Yeah. Okay, I'm judging by the blank looks on your face. Let's step through. Let's step through what it'd do. Okay, it's got an array. Essentially, it goes, is this the maximum value? What's the answer? Is this the maximum value? Is this the maximum value? Okay, you all could understand that because you had intuition. You could all understand that because you had intuition. When I said, is this the maximum value? How did you know what the maximum value was? Yeah, because you already know it. You already know it because you can see the array. When your computer starts looking at the array, how does it know what the maximum is? How does it know where to start? 20 seconds. Talk to the person next to you. Where's the problems? What could potentially the solutions be? What would it need to do? You can tell because you're looking at the array. What could your computer do? Rohan, if you want to jump around and work with Amy and Peter, that might be more conducive, okay? What could your array, what could your logic potentially need to do? Okay, now you've had some time to think. Its issue. Stop. Now you've had some time to think. You can look at this and know it's going to need something to compare it on. All the information it has is the array. What could it possibly do? Cooper, you and Josh sounded like you had an idea.
Well, so you just have it like 2.
What's it going to set 2 to be? What do you mean write down? You'd have to save it to a variable. Oh, we're going to get into using our subject specific words. So we're going to save 2 or the first, what is it? What do I call all the spots in the array? What are they called? Ends with I. Someone, I half heard it. Thank you, Rohan. I set the first index because guess what? This logic is going to work if these numbers are different. So what are you presuming to set with the first index, or what are you going to do with it?
So then I put the next number down.
So the second index, start using like more subject specific words. Yeah. Yep. Yep.
And
to each other.
If like one of these greater than the other index.
Good.
Then it will like put that down and then it will keep doing compare 7 to 12 like for the next index. See if it's greater. If you can't find any indexes that are greater than the biggest number.
You're presuming to save them all as separate like variables, yeah? You're not wrong. First off, well done, you're right. There is a comparison that happens, but I'm going to take it and I'm going to make it one step easier. You could have not 4 lovely clean numbers. You could have 4,000 numbers, yeah? It's going to be really messy. First off, your logic doesn't have the same intuition, the same brains as you guys just had. It doesn't know, just looking at things, what a maximum is. You have to set a comparative value. You have to compare. So Cooper, you and Josh were on the money. A comparison has to happen. But in order to compare indexes to see if it's the biggest, you have to set something to be the biggest. You have to set something. Something has to be the biggest value. The most logical thing to set to be the biggest value is index 1 or index 0. The first index. The first index is going to have to be set as a variable. What could I call that variable? The max. Yeah, I'm looking to find the maximum. I have to set something to be the maximum to start with, because then it can't go, is that bigger than the maximum? Like, is that bigger? Is that bigger? Is that bigger? It needs to set something. It needs to do a comparison. It's the only way it's going to work. The most logical thing to do when you're finding a maximum or a minimum is to set the first thing, or you're doing anything comparatively. You have to set the first thing. So set first index as max. Yeah? Then what would I need to do? Second index, yeah. Second index, I get the second index, and then what do I want to do?
I just said like name the variable next index.
Oh yeah. Why name it next index, not second index? do third index, do fourth index, do fifth index, do sixth index. I could just keep on incrementing variable, couldn't I? Rather than just going set 2, set 3, set 4, set 5, I could just go set index plus 1. If you're not following the logic, don't worry, we'll get there. Well done, Cooper, good pickup. So set next index variable as 2 initially. Yeah, 2. And then what would I need to do? Yeah. Compare what to what?
First index.
Compare max to next index. I'm going to underline these. I'm actually going to write them in another color. I reckon this is going to work nicer. All right, any variable is black. So max. Cool. Next index. Okay, again, I write my variables in capitals, no spaces. Yeah, makes it clear. So then I'm going to compare max to next index. You don't have to write this down, by the way. I'm going to compare max to next index. There's going to be a comparison. Okay. What's going to happen? Like on that check, what's going to happen? Okay. If next index is greater than max. Lord, this is complicated for me. Yep. What am I going to do? Yep. Okay. Let's see if Cooper's logic works. So I set that to be the max. I set that to be the next index. I compare the 2. Is that greater than that? Is that greater than that? Because that's what I've done. No. Done. According to the logic. Good so far. Did the compare. What else do we need? I've done the compare. It's cool. What do I need to do through the array? Yeah, I have to keep on jumping, don't I? How would it be able to, like, I set next index, sorry, Sean. I set next index to be 2. What would I then need to do once I've done the compare? I heard it somewhere. Well done. Regardless, I'll need to do that. Even if it's maxed or even if it's minned, regardless, I'll need to do that. So set, sorry to this Zoom recording if you can't see this. Next index to be itself, I'm going to +1. Cool. Let's see now if this is going to work. So first number is max. That is the next index. Okay. Is 2 greater than 7? No. Then I need to set the next index to be 2 + 1. Okay. Oh, hold on. That's the max. Yeah, it is. Whoops. I did reverse logic. I was like, wait, 7's bigger than 2. Where did we go here? So is 2 bigger than, that's the max. Set next index to be that variable. Compare max index to that. If that is greater than that, is 7 greater than 2? Yeah, so that's going to be my new max. And then what am I going to do with this last new line? Okay, so then I'm going to compare. Oh, but then I'm not going to do anything. Hold on, because that was just the end. What did you say that we needed? We need some kind of repeat from where to where? Cool, I need some kind of repeat in there. Not too sure which one yet, but I need some kind of repeat. I'll just leave it as repeat to check my logic. No, because how long is the array? Unless I do an array check. Yeah, but I only know that there's a for loop because I know there's for. I need this logic to work for everything.
That's what I meant. I get the amount of indexes
For I to end of array. Yeah, I like that logic. There's a couple of ways to do it. Anyway, so then I keep on repeating. Is 7 greater than 12? Sorry, is 12 greater than 7? Yes. So then it's going to set the max to 12. Does it check again? Does it check again? It does. It doesn't stop. That's a wondering. If you get a question that says, and then once it's found it, it jumps out, then you'll have to go check your logic. Is 6 greater than 12? No, it jumps out. Are you happy with that logic so far? Has it worked? Cool. By which means are we going to repeat? Cooper, do you want to give your suggestion?
I was just by getting that.
Yep. So most languages have a library function that says something along the lines of returns a number of indexes in the array. Then how would you use it in a for loop?
Well,
For I equals 1 to end of array.
yeah.
You'd send a variable called end of array and you put the library function that says find the number of elements. And then you'd say from the first one to the variable that says end of array, because that has how many. That'd work if there was 4. That'd work if there was 200. In logic, you can also write it a bit differently. Okay. Yep.
Would you go like for a repeat until
End of array. Yep. Yep. While not at the end of the array, it's a bit more dodgier, but let's have a look in a minute, not yet. In a minute, we're going to see how close we are to the course specs. Before we go there, I'm just going to give you a reminder. We're dealing with arrays. We're dealing with arrays. So when we write our logic, we are going to have to adjust how we've written these variables ever so slightly. When we say the first index, how would I actually write that? In terms of this array, how do I actually write the first index? I've got the name of the array. As soon as I have the name, I can work it out. Numbers, brackets. What do the brackets represent? Thank you, index. I keep on hearing it from the back. The index, it represents the index. Why did you say 0, not 1? Okay, you got 2 options here, team. You got 2 options. Okay, it always starts at 0. I know some of you might not have had much experience with arrays last year. Most programming languages have a 0-based array indexing. That's a big fancy way of saying the first number is 0. As programmers and logic people, I really can't move beyond the fact that G block, the bottom level, is level 1. It kills me. That's why you have ground and then you have level 1, level 2. Yeah, you start at 0. The first thing is 1. It's like you're born at 0 when you have your first birthday. It's like a different way of understanding the logic. It doesn't matter which way you write it in your pseudocode. Most of the time in the course specs, you'll see it written as 1 though, because it's logic. You can write 0. You just have to put a little thing on your paper to say, have used 0-based arrays. Don't care which one you do. Markers will pay both. Okay, so set numbers as max. Set next index variable. When I'm comparing it, I'm saying compare it to the next index. It's a number like 2, a number like 3, a number like 4. Those 2s and 3s and 4 indexes are indexes in what? What array? The numbers array. Please stick with me. A couple of people have like tuned out. Please listen. When I say set next index variable as 2, okay, what I'm actually setting numbers next index variable. Actually, no, I'm not there. My bad. Setting next index variable as 2. When I'm doing this is where I do it. Numbers. Sorry, I apologize about that. Compare, what are my numbers? When I'm doing the comparison, that's actually what I'm doing. That's actually what I'm doing. Because I'm comparing numbers 1 to numbers 2 initially, and then numbers 3, and then numbers 4, and then numbers 5, et cetera, et cetera. If I just wrote next index, I'd actually be comparing that with the number 2, the number 3, the number 4, the number 5. Yeah, very easy mistake to make in logic, very easy mistake to make. But do you see how that's a bit different? Okay, now what I'm going to do, we're going to do this and kind of break down the instructions for each section of a standard algorithm. There is a super particular way to write this. The point of this is so you can kind of understand how the logic may work. What I want you to now do is compare the pair. Have a look in your course specs. Have a look in your course specs. That's how they write out the logic. Check to see how close or on the money we were. Go. Have a look at your course specs. Yep. It is on page 60. It's the page after I told you to look at. You're welcome. We got one thing wrong, and it's where when I had to change my comparison, that's why I changed it around. It's because I didn't write it as particularly as I should have. Cooper, why were you nodding before? Yeah, it's pretty on point. What are they doing on the first line of this? And if you've got your course specs open, start your annotation. If you don't have your course specs open, guess you'll be watching my recording later. God, I hope I'm still recording. Winner. You're welcome. Oh, not that. Okay. I'm going to share my screen on this recording. That's going to even be better. Hello. On. Winner. So what are they doing on the first line? What's that first line? Let max equal element 1. What are they doing? Setting the max to the first. Does our logic still work for this example? Cool. If you have your course specs, let's annotate it. Set the first index to be the max. Why do I need to do that, Will? Why do I need to set the first index to be the max? So you have something to compare it to. Write it down. Set the first index to be the max. If you don't think you need to annotate it, that's cool. But like set. It's actually talking to Josh, but that's okay. Okay. Let max index equal 1. This is a cool thing because this is a bit weird. We didn't include this. To work out what the hell's going on there, let's draw our eyes down to what actually outputs out of this algorithm. It says display the highest value is this value at position this. So what does this algorithm output? We hadn't even got to output. We didn't have anything outputting. Yeah, we were just working on the base logic. This algorithm, what does it do? We could display the max pretty easy. Hey, we just write a display max once it gets to the bottom. But what's the additional thing that this logic did that, like, to be honest, like I'm not sold on it. It's like here nor there. But what does this also do? Yeah, it also tells you. So if we were to get like our logic to match the same, we just have to set a tracker. So around this time where I reset the new max, I'd also have to reset the new index. Here nor there, if your question says, and then display the maximum index, you could make it work that way. Okay, so the second line is doing that. We're going to breeze over that for a little bit and we can come back at the end. So we set the first element to be 1. What's this I variable? Set I to be 2, and then repeat this comparison, element I with max. What's the I variable doing here, Cooper? So it's setting this to be the max. We were cool so far. Will, you thought you had an idea? Yeah. What's its function within this logic? What's I's function within this logic? Where do you see I again? Yeah, yeah. So it says let I equal 2. You see I here. You see I here. You see I there. What does it usually represent in logic? Yeah, index. It's the next index. We called it the next index because that made sense for us. Yeah, it's performing the same function. Logic will tend to replace anything you're doing with an index, particularly if you're what we call incrementing that index. So next index in our logic changes, doesn't it? Starts at 2, then it goes to 3, then it goes to 4, then it goes to 5, then it goes to 6. If there was 400, it'd go all the way to 400. That's called incrementing. When you increment anything in logic, instead of having the variable name next index, it often just calls the variable I. Anything to do with an index, particularly if it's incrementing, it just calls it I. Okay. You could call it purple pants if you really wanted to, it wouldn't matter. I called it next index, or I call it I because it's indicative of what it does. Okay, make sense? Do you see how I could still write next index in this logic and it wouldn't be a problem? Yeah, same thing. Markers like I is easier to use. Sometimes I use T when I'm really tired and I can't see the screen and I need something that doesn't look like a 1. Okay, set I to be 2. Oh damn, he's gone. Of course, I didn't do that. Repeat until. It's wrapped it in a repeat until. Cool, whatever. You could wrap it another way, but it's wrapped it in a repeat until. Let's look down and see if our logic works. If element I is greater than max, what would be the issue if I said if max is greater than element I? What would it be doing? It'd be comparing if 2. That's okay. Are you still with me? No? Okay. Are you with me up until this point? Is everyone with me until here? Okay, cool. So far, we've nailed it on that. We've nailed it on that. We're now up to the loop. I see the loop here from the loop from there to there. Yeah. So if you had let I equal 2, just write a note down to say starts at the second index. Has already set the first index to be max. So I don't need to compare the first index to itself. That's the logic. Set the second index to be max. Then I know I have to repeat the instruction because I demonstrated that before. I have to repeat the instruction. Otherwise, I only do one comparison. Cooper, why? Yeah, that's actually going to work when I do the opposite. Okay. I need to ask myself, I've set this to be the maximum. I'm comparing all these. I compare the new thing to what I've set. The new thing to what I've set. The new thing to what I've set. If element I is greater than max, then let max equal element I. Compare max to numbers next index. Essentially what I was doing there as well. Just make sure I flip it. To be honest, I wrote it the wrong way. That's why I remember I was comparing 2 to 7 and then I was like, why did I get the wrong answer? I wrote it the wrong way. If next index is greater than max, if it is, yeah, if it is greater than max, let the max to be that. I only want to change the max if it's greater. I only want to change the max if it's greater. I only want to change the max if it's greater. That's why it does the compare. And that's why incrementing is outside of the comparison. I have a repeat. I check, is it greater? If it is, I execute these lines. If not, I increment I. When do I keep going until? I is greater than the number of elements in the array. You in your logic, in your pseudocode, can write num elements in the array. 100% happy. You don't have to do the library function check. They'll take that. And then for some reason, we wanted to display this. So let's get our annotations down. This line checks to see if the next index is greater than the max that is set. Checks to see if the next index is greater than the max that is set. put a line around these two lines off to the left. If you've been doing your annotations to the left, I want supplementary information. So I'm going to get 2 annotations on this section. This is like off to the other side that you haven't been writing on, which I assume is this way. These lines only execute if these conditions met. So if the above conditions met, these lines only execute if the number that you're comparing to is greater than what the max is. These lines only execute if what you're comparing to is greater than the max. Okay. And then for each line, Rohan, what's it actually doing here on this one?
It's changing the max.
Yeah, it's changing the max. Awesome. It is overriding the max variable with the index that it was currently compared to. Overriding the max variable with the index that was currently being compared. And this stupid one is recording what index that is for some reason. I'm not really sold on it, but sure. Recording what index that was. It was 2, then it was 3, and then it's still 3 by the end. Awesome. Okay. What's this line doing here? Someone who's not Cooper, what's this line doing here? I equals I plus 1. Once I've done the comparison, if I've needed to, close, it set the new max up here. Yeah, well, not the max index, the next index to compare to. The next index to compare to. I say I started index 2 because I've set index 1 to be the max, so it doesn't need to compare to itself. I check to see if number 2 is bigger than the max. If it is, I replace it. Otherwise, I've done 2. Where do I need to go on to? Index 3. And then once I do index 3, where do I need to go on to? 4. And then once I've done 4, where do I need to go on to? 5. If I don't do that, you'll end up in our first problem of comparing 2 things and going, well, that was fun, and not being able to move. Does that make sense? Forgetting to increment is one of the most common logic problems in people's codes. Why is my loop not working? Oh, whoops, forgot to increment. That's why I'm not spitting out the numbers that I meant to. Forgetting to increment is the biggest problem when you code. You're like, gosh, forgot it. So this is incrementing I. So I can move on, write this down, incrementing I. So it can move on to checking the next index. Once it's done one check, it can move on to the next index. Why is this condition? This is the condition, right? So repeat until. The condition is at the end. The condition whereby which these instructions repeat is until I is greater than the number of elements in the array. Why do I need a condition like that? Why can't I just repeat? If I didn't have that condition, what would it do once it did? Oh, no, oh, no, oh, no. What would it do if it was just going to continue repeating? Try to continue. What issue is it going to run into with my 4 indexed array? Yeah, probably. It's just going to keep running and checking nothing and checking and moving up memory and checking and check. Yeah, always have to give it a boundary. Give it a boundary. It won't cry. Yep. Does anyone have any questions on that logic? Does that logic make sense? Great. I'm going to stop this Zoom recording then.